What exactly are bases? Think of them as the chemical opposites of acids. While acids are known for their sour taste, bases are recognized by their bitter flavor. Bases are substances that love to accept protons, those tiny positive particles that are crucial in chemical reactions. Remember the pH scale? It's like a ruler that measures how acidic or basic a solution is. Acids are found on the lower end of the scale, ranging from 0 to 6. Bases, on the other hand, are on the higher end, from 8 to 14. Right in the middle, at a pH of 7, we have neutral substances like pure water. Bases are all around us, playing vital roles in our everyday lives. From baking soda in your kitchen, which helps in cooking and cleaning, to soap in your bathroom, which keeps us clean and fresh, these substances are essential in our daily routines and activities. But what exactly makes a base a base? Let's dive deeper and find out together. We have three brilliant minds to thank for defining bases: Arrhenius, Bronsted-Lowry, and Lewis. Each of these scientists contributed a unique perspective that helps us understand the nature of bases in chemistry. Arrhenius said, "Bases make hydroxide ions, OH, when dissolved in water." This was a groundbreaking idea at the time, providing a clear and simple way to identify bases. Think of sodium hydroxide, NaOH, dissolving, creating those slippery hydroxide ions. These ions are what give bases their characteristic slippery feel and ability to conduct electricity in solution. Bronsted and Lowry chimed in, "Bases are proton acceptors." This definition expanded our understanding by focusing on the interaction between acids and bases. They realized that bases love to snatch up those positive protons, H+, from acids. This proton exchange is a fundamental concept in many chemical reactions, especially in biological systems. Then came Lewis, saying bases are electron pair donors. His definition brought a new dimension by focusing on the role of electrons in chemical bonding. He focused on electrons, those tiny negative particles, and how bases generously share their pairs. This sharing of electron pairs is crucial in forming stable chemical compounds. These definitions might sound different, but they all point to the same idea. Bases love to neutralize acids. Whether through hydroxide ions, proton acceptance, or electron pair donation, the goal is the same. It's like a game of chemical tag, with bases always ready to tag those acidic protons. This playful interaction is what makes chemistry so fascinating and essential in our daily lives. Bases have some telltale signs that make them easy to spot. Ever touched soap? That slippery feeling, that's a classic base characteristic. They also tend to taste bitter, but please don't go around tasting chemicals. Remember litmus paper? Bases turn red litmus paper blue. They're also great conductors of electricity when dissolved in water. Think of those electrolytes in sports drinks. Some of them are basic, but be careful. Strong bases can be corrosive. They can react strongly with acids and even damage your skin. Always handle bases with care and wear proper safety gear. Identifying bases, detectives of chemistry. How do we identify a base? Well, we can use indicators like litmus paper. Remember, bases turn red litmus paper blue. We can also measure pH using a pH meter or special pH paper. There are different kinds of bases. Strong bases like sodium hydroxide completely ionize in water, releasing all their hydroxide ions. Weak bases like ammonia only partially ionize. Understanding the strength of a base is important because it tells us how readily it will react. Strong bases are like the race cars of the chemical world, while weak bases are more like the family sedans. Acids and bases, a dynamic duo. Acids and bases are like the yin and yang of chemistry, representing two fundamental and opposing forces. They're opposites, but they balance each other out, creating harmony in chemical reactions. When acids and bases react, they neutralize each other, forming salt and water, a process that is both fascinating and essential. This reaction is called neutralization, a fundamental concept in chemistry. Acids and bases are essential in countless processes, from digesting food in our stomachs to manufacturing life-saving medicines in pharmaceutical labs. They play crucial roles in biology, industry, and the environment, impacting everything from our health to the ecosystems around us. So there you have it. The dynamic duo of acids and bases is integral to our understanding of chemistry. Bases, the pH powerhouses of the chemical world, they are just as important as acids in maintaining balance. Understanding bases is essential for anyone interested in science, as they are involved in numerous chemical reactions and processes. Whether you're a student, a teacher, or just curious about the world around you, keep exploring the amazing world of chemistry. There's always something new to discover and learn.